Okay, good evening students. Okay, today we will move on to the second part of our topic, waves. Okay, we will look at the second part, which consists of the property of the wave itself. Okay, just take note that there are two types of wave that we mentioned in the previous section. Okay, they are longitudinal wave and transverse wave. In this section 11.2, when we look at the property of wave motion, the wave that we are interested in, or the wave that we are discussing here, is actually transverse wave. So in this section here, 11.2, the wave that we are referring to, the property of the wave actually is referring to transverse wave. Okay, so how about longitudinal wave? Longitudinal wave will be covered in the following topic known as sound. Okay, so if you are looking for longitudinal wave, okay, you can go to chapter 15, okay, and look at the video or look at the video explanations that you are of interest. Okay, if not, 11.2, I repeat, these sections we are actually discussing about transverse wave. The wave itself, okay, the basic thing that we are looking for is actually what we know as the crest and the trough, the highest and the lowest point of a wave. Okay, simply said, okay, like I mentioned, the crest is actually the highest point of the transverse wave, and the trough is actually the lowest point. Okay, it's very quite obvious. The highest means the tallest, and the lowest means the lowest. Okay, so R and U will be the lowest point, will be what we call the trough, and the highest point PSV is actually the crest of the wave itself. Okay, we just need to take note of like the terminology like crest and trough. Why? Because the questions sometimes we actually use crest and trough to denote the location of the wave itself. Okay, for example, P and S. If I don't say P and S, I can actually use terms like successive crests. So you or neighboring crests, okay, to denote P and S. So as a student, you need to know which area the question is actually referring to. Now, the other one that we look at will be amplitude. Amplitude, take note, is what we call the maximum displacement. But this maximum displacement is measured from where? From the rest point to the highest point. Or sometimes we say the lowest point also. But it is what we call max. Okay, but which means that in terms of magnitude, in terms of maximum, it can be from the rest to the crest. So this is what we call positive amplitude plus A. If I measured the other way, from the rest position down to the trough, okay, it's also called amplitude because it's maximum in another dimension. So what we have, it will be negative A. So in terms of amplitude, you actually have two numbers that you're looking for, plus A and minus A. Okay, but take note, when we talk about magnitude, amplitude is talking about the distance, is measured in meters, cm, and sometimes even mm. So plus and minus, positive and negative, the plus, the sign actually means whether it's measured from the crest, which is positive, or negative, which means measured from the rest to the trough. Okay, but the magnitude is actually the same. The plus and minus just indicate the direction. Now, the other terminology that you tend to hear quite often in describing the wave is what we call in phase. When we say 2 points, okay, 2 points on the wave are in phase, what do I mean? Okay, in phase, basically it means that the 2 points or the points that are in phase are actually having the same direction, speed, and displacement. AKA, what I normally tell students is that in phase, basically it means that the points are actually exhibiting the same motion, the same action, or what we call motion. Okay, what do I mean by this? Okay, for example, when I say PSV are in phase, okay, particle PS and V are in phase, meaning, so let's look at the wave first. Okay, so while I swing the wave, okay, let's assume that the wave is moving from left to right. So this will be the wave motion. Okay, so which means that at this instant the wave will look like this. At maybe 1 second later, the wave will move slightly to the right. So I will say the wave will look like this. Okay, so the dotted line will be, let's say, will be what will happen at 1 second later. Okay, so the solid line, the brown color one will be t equal to 0 second currently. So you'll find that the dotted line actually move right, which symbolize the movement of the wave, okay, from left to right. So at this point, you will know that the point P originally is at here, and 1 second later, okay, remember, for transverse wave, the particle is only moving up and down. So at 1 second later, particle P is actually here, okay, which means it has moved down. So which means from 0 to 1 second later, particle P actually moves down. Okay, and same thing, when we say PSV is actually the same here, what we are looking at for is actually PRS is actually moving downwards, okay, and V is actually moving downwards. Okay, pardon me for my drawing, it's slightly inaccurate, so let me redraw a bit first. Okay, so which means the wave I'm looking out for should be something like this. Give me a minute. Okay, in phase means they have the same point, same location, same motion. So which means it will be somewhere here. Okay, so I will say that S and V, they are actually moving downwards. So in 1 second later, particle P, S and V, they will actually move down. Okay, they will move down by the same amount. They will be moving at the same speed. They will be moving downwards towards the rest position. They will be having the same directions. So you'll find that when I say they are in phase, the particle have the same action or same motion, what I'm referring to is actually they will be moving at the same speed, they will be moving in the same direction, and their current displacement, their current position from the rest position will be the same. Okay, this is what we mean by in phase. So likewise, you can take a look. Q and T are actually in phase. Example, okay, Q is here. 1 second later, Q will be upwards. So Q actually move upwards. T, same thing. It is at the rest position. T later on, it will actually move upwards, which is T here. So you'll find that Q and T are actually two particles that are in phase, and they are actually, how do I know they're in phase? Because 1 second later, Q and T actually move upwards in the same direction, in the same magnitude, having the same displacement from the rest position. So likewise, other point like where R and U, they are also in phase with the same explanations. So when we talk about in phase, students, you need to really look at what happened currently and compare it to 1 second later. So there must be a time frame involved, such that the particle, whether they are moving in the same direction, same speed, same displacement, it will be clearer if you compare before and after. Okay, so just to take note of this when we talk about particle in phase. How do we check them? Now, wavelength, okay, the distance between the two crests, okay, it can be it can be from crest, it can be from trough, it can be from the rest position, but the important thing is between 2 points they are in phase. Okay, so that's what we mean by wavelength, okay, the distance between them. After that, we have period. Period is the time taken for one complete oscillations. Okay, and the reverse of it, it will be frequency. Okay, 1 second I can produce how many waves. So they are actually like related to each other, but they are just defined differently. So take note of the formula. F equal to 1 over T. Period is capital T. Okay, the formula will be Hertz. Okay, and the next formula that you see will be what we know that is the speed of the wave. Speed of the wave, okay, I will not dwell much into it. The formula that we have is V equal to F lambda. Okay, remember, lambda is the wavelength. Okay, lambda here is the wavelength. Okay, followed by F, which is the frequency. Okay, so the formula, just take note of it. Now, there one thing that we have, when you look at the wave as a whole, when the wave moves out, it propagates out, it moves out, you'll find that there is this wavy or there is this up-down motion. So what does the up-down motion means? Okay, is the up-down motion is actually what we call a wavefront. Okay, wavefront is just an imaginary line that you actually see. Okay, just that it connect all the points together. Okay, that's what we mean by wavefront. Okay, it's that up and down crest that you actually see when the wave move across the river or move across the water tank. Now, when we look at the graph, when we look at the description of the wave itself, what we are actually describing, or what we are actually describing, the property of the wave is based on the wave profile, or what we call the graphs of the wave itself. What wave? Transverse wave. So transverse wave can be depicted into two type of graph. One we have here, which is the displacement distance graph. The other one is displacement time graph. Okay, they are usually called the profile of the wave itself. Now, the displacement distance graph, in short, this graph is actually a duplicate, a snapshot of the wave itself. So at this particular time, at an instance, at a fixed time, what you are going to do is you are going to imagine you taking a picture, a snapshot, and that snapshot is actually the wave profile of the graph, which is the displacement distance graph. So which means that whatever you see physically, is actually translated in the graph, exact dimension, everything, and that will be what we call the displacement distance graph. And displacement distance, which means the x-axis is distance, it will give you certain information. For example, since it's measured in distance, the distance between successive crests will be what we call the wavelength. Between the rest and the vertical axis, it will be the amplitude. So these are the things that we are actually looking at for displacement distance graph. Same thing, take note, displacement distance graph is a particular point in time. So if you look at it at multiple timing, means you are looking at multiple snapshots of the wave itself. So there will be multiple displacement distance graph for different timing. Slight convention, take note, the upward, if we take it as positive, downwards we take it as negative. So when we talk about the particle moving up and down perpendicular to the wave motion, we will take up as positive, we will take down as negative. Some convention that we take. The other way of representing the graph is what we call the displacement time graph. Take note, displacement time graph is a snapshot of a particle, but this snapshot is just not a single snapshot, it's a snapshot of a cycle. So which means we will actually trace the motion of the particle across time. So when we talk about snapshots, we're actually looking at multiple snapshots, but it's of a particle. So how do we look at it? Let's look at it in detail. So here, take note, this is the displacement distance. So at each timing, 0, 0.5 at each timing. So you'll find that if you focus on particle Q at time 0, particle Q is at the rest position. So this is where particle Q is. So this graph, displacement time graph, let's say it's particle Q. At time 0 is actually 0. And you'll find at 0.25, particle Q is actually at the highest position at 5. So what you do is at time 0.25, particle Q will be at 5, the amplitude 5. At 0.5 seconds later, it comes back to the rest point, so it will be at rest again. So if you trace it for multiple timing, you will have multiple locations, or multiple representation of Q at time interval. And once you have all the locations, you will draw the graph, and that will give you a displacement time graph of a particle of the wave. And same thing, because I'm looking at time, the one cycle here I will have is periods. So in a nutshell, what we are looking for is that we have different properties of the wave, and we have all these properties depicted in two types of graph, which is displacement distance and displacement time. So students, you have to be clear on what graph you are looking at and how do we achieve at different graphs. If you are still unsure of the graphs, feel free to relook or rewind or revisit the videos, to get a clearer understanding, because the main bulk of 11.2 is actually these 3 items. If any comments, leave it at the comment bar below, and do let me know. Okay, thank you.